Alright, in this video I'm going to go through these two reactions, so the hydration and dehydration, and I skipped over doing the functional groups just because I don't think it's necessary to see me circle those. The key kind of tells you everything you need to know, but for these I'm going to explain how I get to the answer. So with the first one, we have skeletal structure of an alkene. And hydration means that water is added in the presence of acid. So water is going to add to this double bond. So the double bond is going to go away, and in its place will be an alcohol. And so if I draw this structure out here, there we go. Have another one here. So the alkene is gone, in its place there is an alcohol. And I'll draw the hydrogen as well. So you show that that we added H2O over this double bond. Now this isn't the only place that the alcohol could be. The alcohol could also be on the other carbon. The alcohol could be right over here. Okay, both of these are correct. You only need to write one of them, but just remember that the alcohol must go on either this carbon or this carbon. It can't go anywhere else. And I'm just showing the H for emphasis. You wouldn't necessarily have to draw that out, but show that to demonstrate that it is adding water, H2O, to that double bond. Okay, down here, these two are both condensed structures. So same idea here, water and H+, and the double bond goes away, and in its place, I'm going to draw that H, and I'm going to draw the OH down here. And then the other two H's are going to be on the carbon next to it. And then I'll just finish out with the remaining structure. And remember, we could draw the CH3 like this, H3C, to emphasize that the carbons are connected to each other. It's not going through a hydrogen. And similarly as with the last one, the OH could be on this carbon as well. Okay, so the OH could be here, or it could be on this carbon, and then this H would end up over here. You can see that in the key. On this one, this thing kind of printed all wonky, so I'm going to draw the answer down here. We have the H3C down to this C, and remember that double bond goes away. So I'm going to go ahead and draw the OH here and H up there, and then this one would be a CH2, and then all the remaining CH2s. So it's 1, 2, 3, 4 CH2s, and then a CH3 at the very end. And the same way, the OH could be on this carbon because the double bond was connected between the number 2 carbon and the number 3 carbon. So the OH could be here, or it could be here. Alright, so that's hydration. Now on the back we have dehydration. So this is where we start with an alcohol. All of these are alcohols. OH there, OH here, and the OH is here on this one. We also have an ether group here that's not involved in the reaction. With dehydration, we add heat and acid, and that's going to get rid of the alcohol and replace it with an alkene. So I'm going to draw this exactly as drawn here, except that I'm going to draw an alkene between this carbon, and this carbon. Now I could also draw an alkene between this carbon and this carbon, keeping in mind that I have to make sure that each carbon only has 4 bonds. So if I draw it with the other one in mind, I've got to be careful not to put an H here, because I've got a double bond there. Okay, so there's no H on this carbon because it's got 1, 2, 3, 4 bonds here. So again, just going back to this structure, the double bond could show up here or it could show up here. It has to be connected to the carbon that had the OH on it. All right. This one here, there's only one option. Notice how this OH is on the very end of this molecule. So the double bond can't be between this carbon and anything over here. There's nothing over here. It has to be between these 2 carbons. So that makes the job easy here. Last CH2, and then whoops, actually that would be just CH. Have to get rid of that H here, and this remains CH2, like so. And I guess I forgot to mention that water is a product in a dehydration. So this, again, the alkene must go between these 2 carbons. It might be helpful to just star where the OH is, and then note that the alkene has to be from this carbon to some other carbon. If we were to star this one up here, you can see that the alkene can go here, or it can go here. Whereas with this one, there's only one option. There's only one adjacent carbon. And then remembering that each carbon needs 4 bonds, so I had to get rid of the H here. I had a CH2, it goes to a CH. All right, last one here. Once again, there's only one option. If I star the carbon with the OH, it only connects up with one other carbon, so the double bond must go here. It's going to be CH2, the double bond. I'm going to get rid of that H because that carbon is connected with 2 other carbons, or well, I guess it's connected with an oxygen here, but it has its 4 bonds, so there's no room for that H. And then that's what the result is, plus water. I guess I should draw the arrow indicating the heat and the acid. All right, I hope that was helpful for those 2 reactions. Like I said, in class we'll learn more reactions than these 2, but for now we'll just stick with hydration, which is adding water to an alkene, and then dehydration, which is removing water from an alcohol. All right.